Yeah, thank you, Maciej, for this wonderful introduction. Now everyone knows my birthday. uh, yeah. Yeah, I'm Mateusz. I work here in this office, and improving development experience and adoption of Membrane is what I'm doing when I have some time between two features. But recently, we with the team we've committed a little bit more time to that field, and I'd like to share with you what we came up with. So Membrane is a generic media streaming framework, but it's focused on live streaming, and it has a pipeline-based API heavily inspired by GStreamer, and it's written in a language called Elixir, which is a high-level and functional language. So, as I said, it's pretty generic, but most use cases we've had are like applications similar conceptually to Twitch, so broadcasting or some streaming and AI analysis on the backend, or some handling some CCTV cameras. So that's pretty much Membrane. I'm going to show you some example where I have it. Oh, here it is. Like this is how creating a pipeline in Membrane looks like. So let me first try to run it, and let's hope it works. So what it does, it receives an RTMP stream and broadcasts it via HLS. So it's pretty much the case for a Twitch-like application. So let's send some RTMP to it. I created a simple utility to do that, and we can watch HLS when it's when the first chunk is generated. Yeah, seems to work. It's here. Let's close that. So that's the pipeline working, and we can also use another utility to see actually how the pipeline looks like. So we have some components in here. So actually, these are the components we created in this snippet. So we're creating subsequent components and connecting them together with the pipe operator. And that's basically the initial idea behind Membrane, that we can explicitly specify each component, each part of the stream processing. So here is the RTMP source that gets the stream from the socket via RTMPs. Here is the FLV demaxer that extracts audio and video. In this case, we only care about video for simplicity, let's say, and etc. Until HLS sync that generates the playlist. So it's all pretty explicit, no magic happening here. You can configure everything. You can replace all those components when needed, and you can plug a new component anywhere here in this pipeline. So this is quite, I'd call it a flexible approach. However, we don't always need that flexibility. That's why Membrane provides beans. So here's another example that does exactly the same thing, but we only spawn the two components, RTMP source bean and HTTP adaptive stream sync bean. And that's it. They cover everything for us. So we can see how it looks like again. Maybe just on the graph. So here we have only two components, and when we look inside, they actually spawn the pipeline for us and spawn on all the components. So it's not like that flexible. You don't have access to each step of the processing, but it's a little bit simpler, let's say. But we've been wondering what we actually have to know to create such a pipeline. And keep forgetting it's here. So actually, you need to know Elixir, at least the basics of it. You need to know the pipeline APIs to set up the pipeline. You need to know what plugins to use and how to connect them with one another, and how to configure them, of course. In this case, we didn't handle any transcoding or audio mixing or whatever, but if you need that, you also have to figure out what to use and how to connect it. And finally, if you need to plug in some code that is not available in the framework, then you need to create your custom element. So you need to learn the API for that again. So that's quite a lot just for the start at least. So we've been working on decreasing like this entry level to the framework. So we created examples, we created more beans, we improved pipeline capabilities, so you didn't have to configure everything by yourself, but somehow the pipeline could auto-configure itself. However, there are trade-offs coming with these efforts. For example, like there's a limited amount of examples we can maintain, and the beans introduce subsequent levels of abstraction. So we can end up having beans within beans within beans within beans, and passing properties through these layers, and reasoning about it can become quite hard. And I learned it myself. And also, when the pipeline auto-configures itself, you lose a bit of the explicitness, and you may not be sure what actually the pipeline does, and that's pretty much against our assumptions. So instead, like finding compromises and figuring out how to not break things and make things like easier at the same time, we decided to create something new, and it's called Boombox. And Boombox is a library on top of Membrane that aims to handle at least most common use cases. And it aims also to have an idiomatic API so that you don't have to learn all these APIs and have something working very quickly. And it also has a simple CLI API so that you can try it out even without knowing Elixir at all. I also have some examples of using Boombox. So this is the very same thing again with Boombox. You just specify input and output, and you can also do that with CLI. So let me try it. So as we can see, it seems to work. And yep, that's pretty simple. You don't have that much power and don't have that much possibilities for configuration. However, it's just 5 or 6 lines of code. Also, what we didn't cover before is that to have like a proper Twitch-like application, we need to accept multiple connections, while here we can only accept one. But I can actually copy that and paste here. Here is a Membrane RTMP server that is configured with some parameters. And the important thing is that it accepts a handle new client callback, which is executed once a client connects. We define the callback here, and the important part is the client reference. So instead of passing RTMP URL here, I can pass a client reference here. And now I can connect multiple clients. And now you think he will stream Big Bug Bunny again. So yes and no, as I prepared a new version. So let's see how it looks like. So that's Big Bug Bunny as if Picasso created it. So that's all thanks to my colleagues from the AI team who created a model that transfers the style like this. And we can also stream some other assets or the same one again. And they all play simultaneously. So basically we created a simple app in, I don't know, 24 lines. So again, that's the goal here, that we can use the simple language to simply create something that works very quickly. And the last example I wanted to show you is not hotdog. It's actually inspired by the great talk from the last year's ElixirConf Europe, Not Hotdog Revisited. So I wanted to do Not Hotdog Revisited here. And in case you don't know what Not Hotdog is, then it's an application created by a character from Silicon Valley series, and its job is to determine whether something is a hot dog or not. So here I implemented not hotdog, and let's check if it works. So I used WebRTC input here so that it works like with a low latency. And I guess I have the front end here, so let's make it on the same screen and try to connect. Cool. So I am not hotdog. The first test is passed. So let's see what about the actual hotdog. Well, it's not sure. However, it's a hot dog, yeah? Is a teapot, a mug a hot dog? Not hot dog. Perfect. So basically, that's Boombox. And I have the presentation somewhere. Okay, let's close it. Like the features or the assumptions behind Boombox is that it works out of the box. And in case it doesn't suit your needs fully, you can always fall back to Membrane, because under the hood, it actually uses the Membrane components. And you can always create the very same pipeline as Boombox yourself. Also, for now, it handles single input and output stream, so up to one audio and video track. And we may support more tracks. However, it still is going to be a single stream probably to keep it simple. But we're going to make it pluggable into the pipelines, so you can plug the Boombox into a pipeline as a bin, and then have it connected to whatever else processing you have and handle whatever streams you want. So for now, it streams via WebRTC, RTMP, RTSP, HLS, and MP4. And handles H.264 AAC and Opus. So that's to start. And we are now working on expanding the supported codecs. And it's going to go fast, I hope, because we already support them in Membrane. Currently, we're focusing on the support for WIP and web and plain RTMP output, and making sure that it all works in all cases and it's quite stable. So these are the things that we are working on now and should be shipped very soon. And so we learned that Membrane is a generic media streaming framework, and you can use it by creating the pipelines that define the media flow. And the Boombox is a library on top of Membrane that creates pipelines for you. And for complex use cases, you can fall back to Membrane or combine both of these tools and hopefully create something wonderful. So that's it for me. And I'm happy to answer any questions if there are.
Before we jump into the questions, I need to say that chat wishes you happy birthday, Mateusz.
Thanks. Thanks a lot.
Any questions? Oh, now there's the light, so maybe I will see some hands going up. So I have a question. Has this been released as a package already, or it's about to happen?
Yeah, it's about to happen. We are about to release it on the package manager, and it's available on GitHub for now.
Okay, cool. Damien.
I really liked the hot dog live demo. That was fantastic. So in the basic Membrane, and this is more of a Membrane question, how automated can you make it? Like, can you, if you were doing like one of these, there's a dozen of these AI things that connect to sessions automatically and then record or analyze or whatever. Would it be suitable for building one of those kinds of agents?
Yeah, sure. Generally, there are two approaches. Either you start multiple pipelines, or you're starting a single pipeline, and you're dynamically spawning multiple elements or bins and dynamically connecting them together as needed.
And if people were popping in and out of a session, right? Like if you had a large meeting that had like dozens of people, Membrane would be able to sort of watch, and as every new person came in, it could respond in some way and deal with all those events.
Yeah, exactly. However, regarding the meeting stuff, so like typical SFU when many streams are input and many others are output, like we've created that product already. However, it becomes quite complex when you use pipelines for that particular stuff. And like the idea behind pipelines is that subsequent elements are quite like independent from one another. And when you have like SFU, when like everyone connects to everyone, and you have to like pass like all those keyframe requests, PLIs, etc., the pipeline may become complicated. So maybe it's better to like start off from a ground and not use the pipeline abstraction from that particular thing. However, in case you have some more like broadcasting thing, or that doesn't change that much, then the pipeline is a perfect abstraction for that.
Thank you.
So do you have any kind of performance comparison between the GStreamer and the membrane? That's question number one. Question number two, do you have any customizations like in, for example, in GStreamer, like introducing queues? So it's like you controlling which thread, what pipeline elements is going on. That's now question number two, and I forgot the question number three, sorry.
I'm not sure if I remember all those.
So number one, performance comparison with, for example, GStreamer.
Yep. So of course, Membrane is slower because it's in a high-level language, and it's distributed like or concurrent by design. And so, but I don't have like any particular comparison because it very much depends on the use case. As you have like tens of plugins in Membrane and also a lot of plugins in GStreamer. So if we had the use cases when it was twice slower and when it was 10 times slower, like we don't we are keep optimizing stuff. However, like this is like having this in a high-level language and having it like concurrent, so that you have for example 99% availability. It's like more important factor. So that's kind of a trade-off. And I think I can answer the second one because like each membrane element runs in a separate concurrent light thread. So basically, and Membrane controls the like how the buffers are, how the packets are sent through the elements. So you don't do that manually usually because the framework does it for you.
All right, thank you very much.
Thank you.
Are there any further questions? If not, Mateusz, thank you very much. And
Thanks
happy
a lot.
birthday again.